today we are going to talk about Kepler's laws. Kepler's law, there are three Kepler's law. Kepler's first law. Kepler's first law are all the planets are moved in ellipse, which is an oval a shape, like the oval, like an egg. That's look like an oval, okay, like an egg, with the sun at one focus. Okay, with the sun at one focus, either at F2 or F1. And then this is the ellipse. And then the sun is here and the planet is here. Actually, the planet. And then the major axis is here. Major axis is which passes through the center of the ellipse. Passes through the center of the ellipse. And then is the longest diameter of the ellipse. And then what is minor axis, which also pass through the center of the ellipse and is the shortest diameter. Let's look at it. The shortest diameter. It is also passing through the center of the ellipse. That is the minor axis. This is the major axis. Just like in mathematics or Cartesian, this is the x-axis and this is the y-axis. Okay, the sun is always at one focus, either at F2 or F1. Okay, now let's move on to the Kepler's second law. Kepler's second law is when the Earth is traveling further away from the sun, and then it moves slower. When it travels near and close to the sun, it travels and moves faster. And then the area of this region 1, region 2 and the region 1 are equal. The areas of these two regions are equal. That is Kepler's second law. And then planets are closer to the sun, they are moving faster. The planets are further away from the sun, they are moving slower. That is Kepler's second law. For Kepler's third law is more about the period. The planet which is closer to the sun, it takes shorter time to complete a circle. For the planet which is further away from the sun, which is the period T2, it takes the longer time to complete a circle. So Kepler's third law, the square of the period of any planet is directly proportional to the cube of the radius of its orbit. The square of the period, which is the T2, of any planet is directly proportional to the cube of the radius of its orbit, which is T1 square over R1 cube, equal to the T2 square over T over R2 cube. Okay, T1 here means like the first planet, it takes a shorter period of time, which is the T1 square over, according to the radius here, its radius. Okay, we have to, it is directly proportional to the cube of the radius of the first planet, which is the T1. For T2, it is the second planet, the period for the second planet to make a complete circle, it takes a longer time, and then because it has a longer radius. Okay, and then T1 means like the period of planet 1, T2 is the period of planet 2, R1 is the distance of planet 1 from the sun, the distance from the planet 1 to the sun. R2 is the distance of the planet 2 from the sun. Okay, thank you.